So again, I can't have these fancy schmancy exponents. So I'm going to let u be that fancy exponent. Whoops. And then when I take the derivative of it, remember I have to do derivative of the outside. So first I'll have cosine of the angle, and then derivative of the inside will be pi. Now I'll have a dx, right, because I would move that over from the denominator. And so I look over here and I say, well, how much of that is missing? And the only thing that's missing is the pi. So I'm going to sneak a pi in there. But that means in front I have to have the 1 over pi. So now I have 1 over pi and the integral of e to the x. And then all of this stuff, oops, I meant e to the u. And then all of that stuff turns into a du. Seriously, Torres? Come on. E to the u. We have only said it now twice. And so then, when I take the antiderivative, or when I integrate it, I'll get e to the u plus c. And then substituting back in the u, I have 1 over pi, e to the sine pi x, and then plus c. Not so scary. I rhymed it. Make sure you add the dx on this, it was missing. So that stuff inside the radical seems like a problem. So I'm going to see what happens if I let u be that. And so when I take the derivative, I'll get 0 minus e to the x dx. And then I go, hey, look at that. I almost have that, right? I got a dx and I got an e to the x. I just need to slip a negative in there, which means I'll need a -1 in front. So let's see what I have now. So this stuff is now u. So I'll have u to the 1/2. I'm kind of liking that. And then all this other stuff here and here is now all du. My goodness, I simplified it. And so now when I power back up, I'll have -1 u to the 3/2 divided by 3/2, but that's the same as multiplying by 2/3 plus c. And so then when I put the u back in, I'll have -2/3 1 minus e to the x to the 3/2 plus c. Wow. I think I get this.